from our NVH training modules, noise and vibration go hand in hand. We also know that abnormal noise and vibration is generally caused by change in the vehicle. A whirring noise from a wheel, a clunk from the suspension, or a growling from the final drive is generally the first sign of a failing component. So it's very important that the precise location of the failing component is identified and rectified before the vehicle is rendered undrivable and unsafe. Locating a noise while the car is in motion has always been a bit tricky. While a screwdriver held to the ear has been the diagnostic tool of choice for many technicians, it just isn't practical in all situations. An electronic stethoscope, or chassis ears, as they're sometimes called, is the best tool for locating and diagnosing problems associated with driveline noise. The equipment consists of a set of attachable clamps that can be placed at selected locations around the vehicle. These clamps have internal sensors that convert noise to an electronic signal and send it to an external amplifier. The headphones simply convert the electrical signal back into sound for the user to hear. In a perfect world, a noise generated in the left rear of the vehicle stays in that area. During the test drive, the technician can easily identify this and begin a visual inspection. Unfortunately, this isn't always the case. Should the noise combine with a vibration and enter its resonant frequency, then the noise will travel in all directions throughout the vehicle, making it extremely hard to locate. We can attach a sensing clamp to a couple of components on the left-hand rear suspension, and then attach a couple to their counterparts on the right-hand rear. If the noise heard while test driving sounded like a rotating bearing, be sure to attach the clamp as close to the stub or drive axle as possible. Most quality electronic stethoscopes are supplied with a location identifier form. Use this to record where each clamp is placed. It's best practice to use the provided Velcro straps to help secure the clamps and cables. Remember that cable ties can be your best friend here. Feed the main harness back into the vehicle, making sure it cannot foul or tangle on driveline or suspension components. Don't attempt to drive the vehicle and operate the electronic stethoscope by yourself. Have another technician help with this task. When the test drive is underway, turn the amplifier on and adjust the volume to your preferred level. Listen to any noise generated from channel 1 and make the appropriate notes on the identifier form. Switch the amplifier to the second channel and take note of any noise or abnormality from here. Continue the test drive while selecting each channel on the amplifier. And again, take note of any abnormal noises and their location. When we have finished the test drive and return to the workshop, we can use the report to isolate the source of the noise. Simply compare the check marks with the clamp location to triangulate and pinpoint the noise. This may mean another road test is needed, but this time with all the clamps localised around the suspect area. The electronic stethoscope can also be used for conventional diagnostics as well. One way this can be done is by checking the sound the injectors make when looking for an engine misfire. Place each clamp on a fuel injector body, secure in position, and route the cable back to the passenger cabin. If the vehicle needs to be driven to replicate the misfire, then this can now be done with the help of another technician. Cycle the channel selection knob and take notes on the sound each injector makes. A correctly operating injector should make a loud clicking sound, while one that is stuck open or not being driven will make a dull thud or no sound at all. The electronic ear has many different uses. Making it a part of your diagnostic routine can only mean less time is spent locating a fault.